Another process is sodification. Sodification is not one of the dominant soil forming processes again. In most inland humid tropical environments, rainfall is high and leaching is strong. And since sodification is basically the accumulation of sodium in the topsoil, sodification usually does not take place in inland settings. However, in coastal lowlands, estuarine settings, or places influenced by marine sediments or saline groundwater, sodium may accumulate locally in the topsoil. This can lead to clay dispersion, dense subsoil, or the development of very high pH. So, sodification is possible in Liberia, but mainly as a localized coastal or marine influenced process than a general inland process. Next one, shrinking and swelling. Shrinking and swelling occurs in soils that contain specific types of clay minerals that expand when they get wet, and they contract when they dry. This leads to cracking, very significant cracking in the soil, and the formation of so-called slicken sides. In Liberia, this process can be present, but it may be not so dominant. The climate is humid, the soils are strongly weathered, so the types of clay minerals that produce strong shrink swell behavior are often not abundant. It can still occur locally, especially where parent materials introduce suitable clay minerals, or where seasonal drying becomes significant. In those cases, we may observe cracks in the soil. Processes that are highly unlikely in Liberia. It shows that the upcoming slides will show processes that do not fit the Liberia environment. Calcification is the accumulation of calcium carbonate in the soil. This happens in dry or semi-arid climates where there is not enough rainfall to wash soluble materials out of the profile. In those environments, different kinds of carbonate minerals move upward or remain in place and gradually accumulate, sometimes forming hard cemented layers. But in Liberia, the situation is completely different. Rainfall is high, the water is constantly moving downward through the soil. That means that calcium carbonate is dissolved and leached out of the profile where it can accumulate. Gypsification, similarly another process that is climatically incompatible with Liberia. It refers to the accumulation of gypsum in the soil, sometimes forming distinct gypsic horizons or even cemented petrogypsic layers. This process requires dry conditions where evaporation is strong and leaching is limited. Of course, in Liberia, the opposite situation dominates. Rainfall is high, water moves downward through the soil for much of the year. So soluble materials such as gypsum, if they are present, are removed before they can accumulate. Another process that is not fit the Liberian environment is silicification. Silicification is the accumulation and sometimes cementation of silica in the soil. This also happens in arid or semi-arid environments where evaporation is strong and water movement is limited. Additional processes, non-pathogenic processes. The upcoming slides are important because they introduce something different from the processes we discussed before. These are not soil-forming processes in the strict sense. For example, sedimentation is not a soil-forming process in the strict sense. It is a depositional process. Material can be transported by rivers, coastal waters, or gravity, and they deposited at a new location. This has a major impact on soils because sedimentation if it interrupts normal soil development. Instead of gradual horizon formation, we get layered deposits with abrupt changes in texture, color, coarse fragment content. In many cases, sedimentation can bury an older soil surface. In Liberia, this is especially common in floodplains, river valleys, coastal environment where sediments are regularly deposited. Colluviation is another process that we should not confuse with normal soil formation. It is the downslope movement and accumulation of materials under the influence of gravity, often with water helping the transport. So instead of horizons forming gradually in place, material is moved from upslope and deposited lower down. That means the resulting profile may contain a mixture of materials of different origin and different degrees of weathering. In the field, these kind of soils appear as very heterogeneous. They show high irregularity, gravels, different kinds of materials on the top of each other. In Liberia, this is most relevant on slopes, foot slopes, and lower landscape positions below eroding uplands. So when we see a profile that looks mixed, irregular, or out of balance with the landscape, you should consider illegal colluviation. Volcanic deposition. Volcanic deposition is also not a soil forming process, but it's important to understand. Volcanic deposition is where ash or other volcanic materials are transported through the air and deposited on the land surface. This creates new parent material and can bury existing soils, effectively restarting soil formation. In areas with active or recent volcanism, this is a very important process because it produces distinct, often uniform layers that are clearly different from the underlying soil. However, in Liberia, this process is essentially not relevant. There is no active volcanisms, and there are no significant volcanic ash inputs affecting soil formation. So this slide is included mainly for completeness, to help you to understand how soils can form in other environments. And the last one that we are going to discuss today is erosion. Erosion is another process that must be recognized before we interpret the soils we observe. It is the removal of soil material from the surface, usually caused by intense rainfall and runoff. In Liberia, this can be especially important on cultivated slopes, exposed lands, degraded surfaces, where protective vegetation cover has been reduced. The major effect of erosion is that it truncates the profile. It removes the upper part of the soil, which is usually the most organic rich and biologically active part of the soil, and may expose the subsoil layers at the surface. As a result, the profile affected by erosion no longer represents normal, undisturbed vertical development. This is very important in field interpretation because if we ignore erosion, we may misunderstand the soil. A shallow, dark horizon may be missing, not because it never formed, but because it was removed due to the erosion. A subsoil at the surface does not mean that soil formation started there. It may mean that the upper horizons were eroded away. So the key point here is that erosion modifies the soil profile by removing materials. It must be identified before we interpret any kind of soil forming process. And this is my last slide for today. I show it this slide again. because this is what we have to remember again. We discussed today the soil forming factors, which are those factors which define what kind of soil can form at a given point of the earth: parent material, topography, climate, biological activity, and the time. And the soil forming processes that are driven by the soil forming factors. And these are those processes that are responsible for the development of horizons in the soil and define the soil properties. And these together are responsible for the soil development. Thank you very much.
Thank you so much, Adam, for that wonderful presentation.